Hey guys, we're looking at the second and third objectives of the multiplying and dividing radicals section. So today we're going to divide. Yesterday we learned how to multiply them. Okay, so the quotient rule says that if you have two radicals over a denominator, you can make it a single denominator or a single fraction over a radical, and then do the division and then simplify. So we've done it before where we broke it up. We can also go back and make it whole. You want to do that whenever, if you notice that the numbers are divisible by each other. So on number one, you would say this is the same as the square root of 14 over 2. Do the division. 14 divided by 2 is 7. Does that simplify any further? No. So that's as far as you can go. Number two, same thing. Make it a single radical, 100 over 5. 100 divided by 5 is 20. Does that simplify further? Yes. So you'd say that's 4 times 5, and the square root of 4 is 2. So you get 2 square roots of 5. Number three, same thing. Make it a single radical, 12x cubed over 3x. Do the division. 12 divided by 3 is 4. And then x cubed over x. Remember, you move the smaller one, and so you'd move the 3 up, subtract 3 minus 1 is 2, x squared. And then you apply the radical. The square root of 4 is 2, and the square root of x squared is, of course, x. So that all simplifies to 2x. If you want to try 4, 5, and 6, now would be a great time to pause it. See how you do. Okay, on this one, you should have said this is the same as 21 over 3. Do the division, and you get 7 once again. Doesn't simplify any further. On number 5, making it a single radical, 48 is divisible by 6. 6 times 8 is 48. And then 4 times 2 is 8, so you'd separate it out using the product rule, and you get 2 square roots of 2. And then 6, 45y to the 5th over 5y. Do the division. 45 divided by 5 is 9. Y to the 5th divided by y to the 1st. Subtract those exponents. 5 minus 1 is 4. And then apply the radical. The square root of 9 is 3. And the square root of y to the 4th, remember you do the division. How many times is 2 going to 4? Goes into it twice with no remainder. So 3y squared when you simplify that. 7 and 8. We've got cube roots, still the same thing. You can make it a single cube root, 32 over 4. 32 divided by 4 is 8. And the cube root of 8, 8 is a perfect cube, it's 2. And then similarly, on number 8 here, 625 divided by 5 is 125. So you get the cube root of 125, which once again, that is a perfect cube. It's 5. So there's how you divide radicals, not too difficult. On back, we're going to do what's called rationalizing the denominator. So mathematicians do not allow final answers to contain radicals in the denominator of a fraction. So to rationalize a denominator, we multiply by 1 in the form of the radical denominator. Remember to check if each radical simplifies before you rationalize, as it will let you deal with smaller numbers. Okay. So let's look. So this is what I'm talking about. You can't have a final answer that has a radical in the denominator. So to get rid of that, you multiply by 1, but in the form of whatever that radical is. So you'd multiply by 1, which is the square root of 7 over the square root of 7. So that is 1. Think about it. Square root of 7 over the square root of 7. Something divided by itself is 1. So we're multiplying by 1, and then we're going to do that. The math. 2 times the square root of 7 on top is 2 square roots of 7. On bottom, we have the square root of 7 times the square root of 7. Well, what is 7 times 7? That's 49. So we have the square root of 49, but that is 7. So I just don't write the square root of 49. Say the square root of 7 times the square root of 7 is 7. A square root times itself is whatever's under the radical. We'll do the same thing on 2 here. To get rid of that square root of 12, we'll multiply the top and bottom by the square root of 12. So On top, we've got 5 times 12 is 60. On bottom, the square root of 12 times the square root of 12. Yes, it's the square root of 144, but like I said, the square root of 12 times the square root of 12 is 12. Something times itself, the radical times itself is whatever's under the radical. Now look at the top. Does it simplify? And the answer is yes. What perfect square divides 60? 4. 4 times 15. So I'm going to write it real small here. Sorry, I didn't give myself enough room. Square root of 4 is 2. So we have 2. I'm coming over here. 2 square roots of 15 over 12. And then look at that answer. Does it reduce? Yes, the 2 and the 12 are divisible to make 1 and 6. We don't need the 1 out front, though. If you divide those both by 2, you get 6 and 1. We don't need the 1 out front. Okay, number 3 here. On top, we have the square root of 1. On bottom, we have the square root of 18x if we separate it out. How do we get rid of that radical? We multiply the top and bottom by that radical. So on top, what's 1 times 18x? Still 18x. On bottom, what's the square root of 18x times the square root of 18x? It's 18x. Look at that top, and what does it simplify is the question. So the 18 is the part that will simplify. What perfect square divides 18? That would be 9 times 2x, right? 9 times 2x is still 18x. On bottom, we have the plain old 18x. What's the square root of 9? It is 3. So we have 3 square roots of 2x over 18x. Does that reduce? Yes, 3 and 18 are divisible by 3. If you divide those both by 3, you would have 1 times 2x and 6x. Now you cannot reduce those x's on top and bottom because this x is under the radical, that x is not. And again, you can't reduce the 2 and the 6 because this 2 is under a radical and the 6 is not. So if it's not under the radical and the other one is, you can't reduce them. So if you want to pause here, that would be awesome. You can try 4, 5, and 6. And then you can comment below and tell me how you did. So 4, nice and easy, just multiply by the square root of 5 to the top and bottom. So that would be 4 square roots of 5 over 5. It doesn't reduce any further. Number 5 here, multiply by the square root of 18 to the top and bottom. 3 times 18 is 54. And the square root of 18 times the square root of 18 is 18. What perfect square divides 54? That would be 9 and 6. 9 times 6. 9 is the perfect square. Square root of 9 is 3. So we have 3 square roots of 6 over 18. Again, it reduces. 3 and 18 are divisible by 3. Divide by 3. You have 1 square root of 6 over 6. Again, can't go any further than that. This 6 is under the radical. This 6 is not. And then the last one, we're going to multiply the top and bottom by the square root of 14x. So 3 times 14x is going to be 42x under the radical. And the square root of 14x times the square root of 14x is plain 14x. Look at your numerator. Is there a perfect square that divides 42? 4 doesn't divide it. Let's see, 4 doesn't. Does 9? No. Does 16? No. 25? That's as reduced as it gets. That one doesn't go any further. Fun. Okay. Now we get to the bottom section, and these ones can be a little bit tougher. So what we're doing up top is we're not just multiplying by itself. What we're doing is we're making perfect squares. So down here, when we're dealing with perfect cubes or perfect fourths, you have to make a perfect cube or a perfect fourth or whatever the index is. So looks like all of my problems are perfect cubes. So I'm going to rewrite those perfect cubes down here just to help us out. It's going to be helpful for this section. So 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And that's probably good enough. Okay, so I'm going to write those down to help us out because what we need to do is we need to make this denominator a perfect cube. So can I make 4, and I want to go and make it as small as possible because that's going to make the least amount of reducing. Can I make 4 a perfect, can I make it 8? Yeah, I can. The quickest perfect cube I can get to is 8. How can I get from 4 to 8? I multiply by 2, but I'm not just multiplying by 2, I'm multiplying by the cube root of 2. So I multiply the top and bottom by the cube root of 2. 5 times the cube root of 2 is just 5 cube roots of 2. On bottom, the cube root of 4 times the cube root of 2 is the cube root of 8. And what's the cube root of 8? It is 2, right? We did that on purpose for a reason, because it reduces to 2, a normal number. And we no longer have a radical in the denominator, so the denominator is rationalized. And it can't simplify. The 5 and 2 doesn't reduce. And again, you can't do the 2 and 2 because this one's under the radical. All right, next one, 3. Can I make 3 into 8? No. Can I make 3 into 27? Yes. 3 times what is 27? 3 times 9. So we're going to multiply by the top and bottom by the cube root of 9. So on top, 7 times 9 is 63. On bottom, the cube root of 9 times the cube root of 3 is the cube root of 27. Okay, so look at the top, 63. Is it divisible by 8, 27, or 64? No. So that's as simplified as the top will get. On bottom, we know the cube root of 27 is 3. Number 9, what's the closest perfect cube I can make? Can I make it into 8? Definitely not. 27, no. 64, no. 125. So I have to multiply by the cube root of 5 to the top and bottom. So that gives me 3 cube roots of 5. On bottom, the cube root of 125, which is 5. So I have 3 cube roots of 5 over 5. Again, it doesn't reduce any further. If you want to try 10 on your own, go ahead and do that. Let's see how you did. What's the quickest perfect cube I can get to on bottom? That would be to 125, so I'd have to multiply it by the cube root of 25 to the top and bottom. On bottom, we would get the cube root of 125. On top, we get the cube root of 6 quarters is 150. Okay, does this simplify? 8 doesn't divide at 27, doesn't divide at 64, doesn't divide. So the top does not simplify any further. On bottom, the cube root of 125 is plain 5. So there you go. That's how you do that. It can be a little tricky, so if you need any help, please do reach out. I'd be glad to help you out. Y'all have a great day, and good luck on the My Math Lab assignment. We'll talk to you soon.